Hello, welcome to the screencast that shows how to automatically deploy AI LLMs from Hugging Face on OpenNebula's powered cloud infrastructure by using the Ray appliance available in the OpenNebula app marketplace. Today we're going to learn how to download and adjust the Ray appliance, how to deploy the AI LLMs from Hugging Face using the Ray appliance, and how to connect to deployed large language model and interact with it. Currently, if you would like to develop an application that's using some kind of large language model, you have few options. Use hosted public usage tools like ChatGPT or Gemini. While it's the easiest option, the advanced models typically are behind the paywall. The resources are shared and you do not have full control over your data. Use AI as a service from one of the cloud providers. It might be more secure than the previous model, but running it in a long term might be very pricey, and you are at risk of becoming vendor locked. You might also need to go through a learning curve for each of the public cloud providers. The third option, install everything from scratch on a dedicated hardware. While it might be cheaper and offers more portability, installing from scratch is not an easy task and may require extra skill set. Plus, it's harder to backup or move from cloud provider to on-premises or between cloud providers. All of the approaches above either add complexity or you have to compromise on either portability, security, or cost efficiency. To solve this, we're introducing the Service Ray appliance that allows you to run open source inference models on any OpenNebula cloud. Here is the list of key benefits of building an AI-ready cloud with OpenNebula. Robust multi-tenancy support, allowing different teams and users to securely share resources while efficiently leveraging GPU acceleration. SRIOV and PCI passthrough, ensuring direct hardware access for enhanced AI performance and reduced latency in the GPU-intensive workloads. Easily deploy and orchestrate large language models from Hugging Face, ensuring seamless integration into the AI workflows. Run custom Python code, allowing users to fine-tune AI models, pre-process data, and automate AI pipelines directly with their OpenNebula cloud environment. True as a service model for on-premises and multi-cloud hybrid departments. To get the Ray appliance into the OpenNebula environment, navigate to the marketplace and search for Service Ray. Export it to the preferred data store. For sake of simplicity, we are going to use the local one. Navigate to Virtual Machine Templates tab and press Update. By default, the appliance is configured to be as tiny as possible, but you would like to give it a bit more resources. In this case, we would like to add a 32 gigabytes instead of 8 gigabytes of memory and add a little bit more CPUs. By default, Ray Appliance is configured to be 8 gigs in disk space. Running the workloads 8 gigabytes is not enough, so let's increase it. Our appliance needs to be connected to the network so we can download the large language models. You may benefit from OpenNebula's automatic network assignment, but for sake of simplicity for this screencast, we are going to directly attach to a specific network. In this case, I would like to benefit from the GPU on this appliance, so let's navigate to PCI device section and let's attach it to the pre-configured GPU. For more PCI pass-through instructions, please visit our documentation. If you will enable these two radio buttons, an appliance will report back with the IP address and also the port and the route of your chatbot so you can access it from the outside. You can additionally fine-tune the context section by configuring root username, password, time zone, hostname, and much more. In this case, I just want to set the password. Let's instantiate an appliance. The necessary resources configured, but you may alter them if you need to. Now we have a few variables that we need to configure. Some of these are optional, but few of them are mandatory. For example, one array model ID, that's the drop-down list where you can select a specific large language model that you would like to import. Currently, there are 3 supported, but there is more to come. Please note, you might need to get an approval from Hugging Face first. You may adjust the prompt based on the purpose of this module. I would like my large language model to act as a code expert. One array model token, that would be your Hugging Face API key. Some additional fine-tuning can be made by adjusting the following variables. One array model temperature, that's going to define the creativity level of your model. One array application file and one array application URL. In order to run a custom Python script, that would be the way how you can get it into the appliance. Once variables are configured, we can proceed to the actual instantiation. Once the appliance is ready, you can locate the access URL in the attributes reported by the OneGate client. Let's connect to it via the secure shell and observe the deployment status. You can run serve status to show the current state of the deployment. We would like it to go from deploying to actually deployed. Please note that it might take a little bit of time. Once it is deployed and healthy, we can navigate to etc. one appliance service.d ray and check the YAML file. This YAML file describes the current deployment. Now we can start communicating with the inference model using our client application. I don't have any specific application, that's why I'm going to leverage the basic client.py that can be found in the Rails directory. I'm going to ask the chatbot to help me out with writing a simple Python for loop. The logs can be found under the tmp ray session underscore latest logs. That contains all the logs of the current session. And this is how it became much easier to run the inference model without attaching yourself to a particular public cloud vendor or relying on the public services. This screencast is produced in the scope of ONEnextGen project. Thank you for watching and see you in the next screencast.